Now we're going to talk about multiplication and division. We'll start with multiplication. When we started the year, we talked about equal groups. So you draw the big numbers. So for example, with the number 3 times 5, you do three circles, put 5 in each one, and count them up. You can also do repeated addition, which we would do 3 plus 3 plus 3 plus 3 plus 3. The other example is arrays, and you could do that very easily on grid paper if you have it. If you don't have grid paper, the other way to do it, you make your rows. So you would do 3 across and 5 down in each one. And count them up. 3 across, 5 down. Like I said, you can do it with grid paper. It makes a perfect square. The one that I think is the fastest is skip counting. 3, 6, 9, 12, 15. There's a lot of ways you can practice multiplication. The time test that we've been doing, you can do flashcards. I have a niece who her teacher actually plays music, and they just count by 3s over and over again, count by 4s, count by 5s, count by 6s, and so on until they have it fast enough where they can multiply pretty quickly. A couple of rules that the kids have learned about multiplication. The commutative property, the order of the numbers does not change the product. 3 times 5 is 15. 5 times 3 is also 15. The identity property, the product of any number and 1 is that number. 5 times 1 is 5. The zero property, the product of any number is 0. And the associative property, the order that you multiply doesn't matter. 3 times 4 times 2, it doesn't matter if you do 3 times 4 first or 4 times 2 first. The product is going to be the same. The other side of that is division, and they have learned that multiplication and division are opposites of each other. They have also done a multiplication and division fact family and learning. Let me give you an example of a fact family. 3 times 5 is 15. 5 times 3 is 15. 15 divided by 3 equals 5. 15 divided by 5 equals 3. And that is a fact family. And we'll talk about that more because there's actually a whole section on the inverse of multiplication and division. But they also need to know that. These are just some examples. And then there is repeated addition. Then when you get into the division side of it, they can use the skip counting. Count by 6 until you hit the number 48. How many times did you count? You can draw 6 circles and put 1 in each one, counting to 48, and you end up with 8 in each one. You can also use the same repeated subtraction. 48 minus 6 is 42. 42 minus 6 is 36. 36 minus 6 is 30. 30 minus 6 is 24. 24 minus 6 is 18. 18 minus 6 is 12. 12 minus 6 is 6. 6 minus 6 is 0. And you did that 1, 2, 3, 4, 5, 6, 7, 8 times. So again, 48 divided by 6 is 8. Those are all the different ways that you can multiply and divide. The next thing that goes with multiplication and division is multiplication and division word problems. And this is basically where they take their skills in multiplying and dividing and they figure out whether they're supposed to multiply and divide in a word problem setting. So for example, multiplication word problems usually talk about making groups of things, 5 groups of something. Division problems typically talk about breaking a number apart, breaking things into equal groups. Multiplication and division, how do I know? They really, really have to make sure they look for keywords. And there's not always a true answer. Sometimes they just really have to think about what's going on and whether it makes sense to multiply or divide. Equal groups is usually talked about in division, but there are also word problems with words like each, and we have learned through us experimenting, working out problems, that each could either be multiplication and division. How many does each person get is division. You're dividing something into equal groups. 4 boxes with 6 in each is multiplication, because you're taking 4 boxes and putting 6 into each one. So see how each could be either one. Putting things into group is usually division. Shares is usually division. If all else fails, draw out what is happening and look what you see in the problem and see if your answer is reasonable. For example, here's just a short problem. I want to share 20 cupcakes with 5 friends. How many will each get? It's an each problem. So it literally could be multiplication or division. So 20 times 5 is 100. Does that make sense? Does it make sense that I'm going to share 20 cupcakes and each child is going to get 100? That's going to go way over the number 20. So we know that that doesn't make any sense. The other side of that is 20 divided by 5 is 4. 4 makes sense. Each of the 5 students could get 4 cupcakes. So you see what I mean about really having to think out the type of problem that they're talking about. There is no exact answer key. There isn't a set of words that tells them, oh, this means to multiply, this means to divide. It's just something that they're going to have to really think about and really work on. One of the most important things is that their fluency in multiplication and division is good enough that they can solve it quickly, solve it easily, so that they have the time, if they need to go back and recheck that in multiplication and division if it needs to be. Thank you.